Hello students, welcome back to JCE Connect series of lectures. So in this particular lecture, I'll be discussing about the numerical problems on gradually varied flow and backwater curve. So I'll be taking a few problems and how to solve the gradually varied flow problems and the backwater curve problems. Okay, so let us take the first problem. The water is flowing through a rectangular channel of 5 meter wide with a velocity of 1.2 meter per second. The slope of the channel is 1 in 2000 and the depth of flow is 2 meter. If the flow is regulated in such a way that the slope of the energy line is 0.0008, find the rate of change of depth of water in the channel. So generally again these kind of problems will be asked for 6 to 8 marks in exam. So here they are asking what is the change in the depth of flow of water, that is to find the rate of change of depth of water. Okay, so first write the given data, and the channel section is a rectangular channel section given. This is the width of the channel at the bottom and this is the depth of flow of water y. The given data are width is given, that is bottom width of the channel is given 5 meter, depth of flow is 2 meter and velocity of flow is 1.2 meter per second. Then the slope of the bed is 1 in 2000 is given, that is slope of channel bed 1 in 2000 is given. Then also the energy gradient, slope of energy gradient line is also given, and we know this formula. So this formula is derived in previous lecture, that is the rate of change of depth of flow along the direction of flow, that is dy by dx is SE minus SEB divided by 1 minus FR square. This FR square is a Froude number and we know the Froude number formula, that is FR equal to V by root of GY, and the velocity is given. Substitute the value of G and Y here. This is the G and this is the Y. We get the Froude number as 0.27. Then substitute back in this equation, we get dy by dx value. So dy by dx value we get as 0.00045, which is greater than 0. And when dy by dx is greater than 0, which represents the backwater curve. So it will be like this. So this is the bottom channel and this is the flow of water in this direction, and this is any obstruction you get, then the water will be rising like this and it is flowing down like this. So like this it represents. So this is what we call as a backwater curve. Okay, this is dy by dx. Okay, next, take one more problem. A weir is installed across a rectangular open channel, thereby raising the flow depth from 1.5 meter in a normal flow to 2.5 meter at the weir. 1.5 meter in a normal flow to 2.5 meter at the weir. The width of the channel is 10 meter and it is laid to a slope of 1 in 10,000. Find an approximate length of the backwater curve. So find an approximate length of the backwater curve considering the average velocity, average depth and average slope midway between the two sections. Take the values of Manning's rugosity coefficient as 0.02. So this is a problem given here and we need to calculate length of the backwater curve. Okay, so let us consider the two sections, section 11 and 22, and as you know, if this is the bed of the channel water is flowing in this direction. If any obstruction comes along the direction of flow, then this water, whatever having the depth, it gradually rises as it approaches the obstructions. Then this is called backwater, and the section or the point where it starts rising and where it reaches the maximum height, this is maximum height we get as y2, and this is a y1, and here we get section 2 2. The distance between these two is length of the backwater curve. Now we have to calculate the length of the backwater curve, and this water, whatever the water is flowing here, this is flowing through a rectangular channel, and the section is being considered between section 1 1 and 2 2. This is the length. Okay, so what they have said here, considering the average velocity, average depth, average slope, everything you have to consider as the average values. Okay, so let us take first at section 1 1 and at section 2 2. At section 1 1, the width of the channel is given, that is a b is given. This is when we have considered section 1 1, the width will be here b1, and the whatever the depth of water will be present at section 1 1 will be y1. At section 1 1, b1 10 meter and y1 will be 1.5 meter. Then a1 v1 sorry a1 will be calculated, that is area of flow, b1 into y1 we get as 15 square meter. Corresponding wetted perimeter also, wetted perimeter will be what, this plus this plus this is b plus 2y. So that is, since we are taking at section 1, b1 plus 2y1, 13 meter. Then corresponding hydraulic radius a by p, that is a1 by p1, we get this one. Then the Chajji's constant c1 is equal to 1 by n r1 raised to 1 by 6. This formula we know it, we get the Chajji's formula. Then corresponding velocity at section 1, so this formula we know, Chajji's c1 into root of rsb, we get 0.55 meter per second. Then corresponding energy at 1, y1 plus v1 square by 2g, this we get. This is for section 1 1. Similarly at section 2 2, again here at section 2 2 you will have to calculate all a2, then wetted perimeter, that is p2, hydraulic radius r2, all you have to calculate, that is v2 also velocity you have to calculate. Since the width of the channel bottom will be same throughout the length, only variable here will be the depth of flow. So b2 is also 10 meter, then y2 is given 2.5 meter, then calculate a2 equal to b2 into y2 we get, then again wetted perimeter we get here, this is the wetted perimeter, that is the length of the channel boundary which is in contact with the water, this much is the wetted perimeter, b plus y plus y. Then correspondingly you calculate the r2 equal to a by p, that is, since we are taking at section 2 it will be a2 by p2, we get this one. Then we know that a1 v1 equal to a2 v2. Since we know v1 and a1 both, then v2 can be easily calculated, or you can calculate by using the Chajji's. Then v2 will be 0.33 meter per second. Then correspondingly you calculate the energy at 2, e2 equal to y2 plus v2 square by 2g. The energy here will be e1, and here the energy will be e2. So here energy will be y1 plus v1 square by 2, here energy will be y2 plus v2 square by 2g, like this we get as an energy this one. Okay, I hope you understood this one. Okay, then next, the value of slope of energy line. Now we have to calculate the value of slope of energy line is calculated by Chajji's formula. This we have already discussed while deriving the equation for length of backwater curve. So you have to calculate the slope of energy line by taking the Chajji's formula or Manning's formula. Chajji's formula corresponding to the flow conditions at the average depth of flow. Okay, so to calculate the slope of energy line, now you need to take the average values of all. So average value of depth of flow, y average will be y1 plus y2 by 2. You have to take the average, that is 2 meter. Then the average area of flow, this one b into b will be remain same. We have to take the y average because we have a two depths y1 and y2 to take the average. Then weighted perimeter b plus 2 y average. Then hydraulic radius r will be average value by a by p. You have to take the average values. Then this is you get. Also from the continuity equation we know that a into v equal to what? That is a average into v average is equal to a1 v1 is equal to a2 v2. Then we get the a average, sorry, v average velocity we get. Okay, then calculate charges by taking the average value of hydraulic radius. We get charges value is this one. Then calculate v average once again. Sorry, we know the v average formula, c root of r into se. From this we get se like this one. Then the length of backwater curve, we know the formula. This is the formula we know, E2 minus E1 divided by SB minus SE. SB is given. Then SE you have calculated by considering the average values of depth, velocity and area. All average values you have taken. So because they have mentioned here, considering the average velocity, average depth and average slope midway between the two sections for calculation of slope of energy line. So that's why we have taken all average values and then we have calculated and then we have substituted in the equation of length of backwater curve. So once we get SE value, substitute in length of backwater curve equation, that is E2 minus E1 divided by SB minus SE. Then we get 17,157 meter, so which will be 17.157 kilometer. So this much is the backwater length. Okay, this one is this much, this one, this L we get 17.157 kilometer. This is the length of backwater curve. Okay. So this is a simple problem and I have to understand the problems. So the moment you get the problems like this, first you write down the given datas, then you write what needs to be find. That is once you get the what is needs to be find, then you will come to know how the problems can be solved. Okay, so this, I hope you understood this one. Practice this type of a problem. Thank you.